Okay, inverse functions. We have this box up here. I know it's got a lot of words in it, and I know people don't like words in math. Okay, but it tells you everything to do. Okay, it explains what inverse functions are. Okay, they are functions that undo each other. Okay, every function that we've ever seen actually has an inverse function. You maybe didn't know that, but every one that we've ever done in Algebra 1 or anything has an inverse, and we're going to talk about those now. Okay? They undo each other. Like they're kind of like opposites. Like one of them is tying your shoe, and the inverse function of that is untying your shoe. Okay? They undo each other. It's kind of like two sides of the same coin. Okay? The way that you find the inverse function is that you switch the x and y. Okay, you interchange the input and the output values. Okay, then the graphs of inverse functions. The graphs of inverse functions look exactly the same as each other. They don't change shape, they change the way that they're facing. Okay, so the graphs look the same, they just face a different direction. Okay, it is actually a reflection across the line y equals x, which y equals x is this line right here. Okay, so it's not an up and down reflection or a side to side reflection. It's a diagonal reflection. Like what's up here flips down to this side. Okay. Well, I'll show you, but I'm just showing you. There's y equals x right there. And that's the line of reflection for inverse graphs. And while we use f of x for the original function, that's been our original all year, even when we do transformations and stuff, the inverse is f to the negative 1, which the way you say it is f inverse, okay? So they're both f's. The inverse just has negative 1. Right, and here's the 3 steps we're going to follow when we solve for the inverse. First, you're going to change the f of x to y. Okay, that means the same thing. Then we're going to switch the x and y in the equation and solve for y again. Okay, it maybe sounds weird, but I'll show you how to do it. And we're going to show graphs. We're going to graph a couple in our notes. You can always put these equations in y equals and look at the graph on your calculator, but we're going to have a few in the notes to see what they look like. Okay, number 1. Okay, I'm going to write original, so you know the one that we're starting with. You don't have to write this every time. I'm just doing it since it's the first problem in the notes. Our original function on this one is f of x equals 2x plus 3. Okay, that's the one we're starting with. Just a linear function. The original is always going to be f of x. Okay, and then first we're going to find the equation of the inverse by doing these steps. Okay, first we're going to make y equals f of x. So instead of f of x, we're going to plug in y there. Every time you're going to do these same steps. Change the f of x to y. Then step 2, switch x and y. Okay, I'm going to do this every time. Okay, so I'm going to rewrite it. X equals 2y plus 3. Okay, now I'm going to solve for y again. Okay, that's how I get my inverse. I undo everything in my original problem, and then I get my inverse. Okay, so how do I need to solve for y on this one? Move the 3. Yes, minus 3. Okay, I'm going to minus 3 on both sides. That gives me x minus 3. Bring down my 2y. Then what? Right, divide by 2. Okay, when you divide by whatever's in front of y, make sure you're dividing everything on both sides. Okay, and my first step was change f of x to y. Okay, all through the middle of the problem, use x and y because it's a lot easier than using f of x. That's confusing. Okay, but my last step, I'm going to go back to f inverse, which is f of negative 1. So here's my equation. Okay, x divided by 2 minus 3 divided by 2 equals f inverse of x. Okay, this is my inverse. Okay, this was my original up here. This is my inverse. And you can always tell which one the inverse is because it's got this f to the -1 that you read f inverse. And if you look at the two equations, my original, it has 2 and 3 in it. And so does my answer, but look, it's the opposite. Here's 2 times x. Now x is divided by 2. Here's plus 3. Now it's got minus 3, okay, because we undid everything. It should have the same numbers in it, just doing the opposite thing. Okay, so this is my inverse equation. On the practice, the first 6 problems, this is all you have to find, is just the equation. What we're going to do on this problem is a little bit more because I'm still teaching you more about inverse functions. But again, this is all, once you've done this on the practice on 1 through 6, you're done. Right here, we're going to look at the tables and see how those look the same. Okay, I'm going to do a table for each one. F of x is my original. And then f inverse is f to the -1 of x. That's going to be in my other one. We're going to compare the tables of these two and see how they look. Okay, so we can always put this into y equals and get the table, but I'm just going to do it. We can just do it with mental math because it's not that hard. Okay, give me some, throw out any number for x. I would say don't make them huge numbers because when we check them, it'll take longer. But just throw out some numbers you want for the x on this one.
2.
All right, I heard 1 and 2. Okay, so we'll do 1 first. Okay, if x is 1, we plug it in here. 2 times 1, 2 plus 3, 5. Okay, so if x is 1, y is 5. Okay, I heard 2. So if x is 2, 2 times 2, 4 plus 3, 7. Okay, give me maybe a negative number. -4. Did you say -4? Okay, -4. Okay,